Hi, welcome to the Olympiad geometry. Let's continue our study. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe to the channel. Let's continue on the geometry Treasure-Incenter, Excenter in circle, X-circle properties. Property 5. Let the in-circle circle I of the triangle ABC tangent to sides AB, AC on EF respectively. BICI meet EF on MN respectively. Prove that AMIN equals to the area of AMIN equals to the area of triangle IBC. I feel that I proved this before, but I'm not sure. So let's just redo it. So this is our triangle ABC here, and the tangent point is E and F, right? And here, this would be the in-center I, and we know that BI meet EF on point M, and CI meet EF on point N. So we want to prove that ANIM, the area of ANIM, equals to the area of IBC. So the first thing is that how can we calculate for the area of the ANIM? Right, notice that AE and AF are tangent to the circle I. So that means AI is perpendicular to EF, right? So AI is perpendicular to EF, which means the area of ANIM can be calculated as half of AI times MN, right? AI times MN. That's the area of the ANIM, okay? And we also want to know how to calculate for the area of triangle IBC. This would be much easier. It equals to half of BC times, call this as DID. Right? Then the question becomes very simple. We just need to prove that AI times MN equals to BC times ID. We just need to prove this one. Look at the figure. We want to find the relationship between AI, BC, ID, and MN. Notice that angle NIM equals to angle BIC. So what about the relationship between triangle NIM and triangle BIC? That would be a question. And if we look at the angle BIN, right, the angle BIN, this one, it equals to half of angle B plus half of angle C, right? It equals to this one plus this one. So that's half of angle B plus half of angle C. And we know that angle AEM or AEF, whatever, this one, equals to half of 180 degree minus angle A, which equals to 90 degree minus half of angle A, which equals to half of angle B plus half of angle C. That means the angle BIN equals to angle AEF. So this angle and this angle, they're equal, right? And we know that this angle equals to this one, the angle NEB, which means angle NEB equals to angle NIB. So we know that NEIB are cyclic, right? We can connect it here, connect it here. Now we know that NEIB are cyclic. That means the angle ENI equals to angle MNI, right? The angle ENI is angle MNI, which equals to the angle ENI equals to angle EBI, which we know that angle EBI is half of angle B, so it equals to angle IBC. Okay, now for the triangle NIM and triangle BIC, we already know that the angle MNI equals to angle CBI, and angle MIN equals to angle CIB. So we know that triangle MIN is similar to triangle CIB, right? And based on this, we know that MN to BC equals to IN to IB. Remember, we want to prove this one. We want to prove that MN to BC equals to ID to IA. Right? We want to prove this one. And now we have this one. MN to BC equals to IN to IB equals to IN to IB. Right? So the question is, what is ID to IA and what is IN to IB? Right, let me rephrase, what is ID to IA and what is IN to IB? IN to IB, because this angle, the angle NIA, this one, let me say this way, because angle MNI equals to angle ABI equals to angle IBC, right? So we know that this angle equals to this one, and also equals to this one, right? That means in the triangle NI, call this point as K, in the triangle NIK and the triangle BID, we have angle KNI equals to angle IBD, and we know they are both right triangles. That means triangle KNI is similar to triangle DBI, right? Based on this, we know that IN to IB equals to IK to ID, right? IN to IB equals to IK to ID. And ID equals to IE equals to IF. So it equals to IK to IE. Right? Equals to IK to IE. Now we know that the angle IEA is 90 degrees, right? Because IE is perpendicular to AB. So angle IEA is 90 degrees, and we know that EK is perpendicular to IA. That means the angle IEK equals to angle EAI. And angle EAI is half of angle A, right? So IK to IE is sine angle IEK, which is half of angle A. So it equals to sine half of angle A. Right? So sine half of angle A equals to IE to IA. Right? And it equals to, because IE equals to ID, so it equals to ID to IA. See? We just proved that MN to BC equals to ID to IA, which means we have AI times MN equals to BC times ID, which means the triangle area of the IBC equals to the quadrilateral area ANIM. We just proved it. Okay, that's for the property 5. And let's see the property 6. Property 6. Circle IA, circle IB, circle IC are X circles of triangle ABC. Let me do this. Let me draw the right here. So you can see that circle IA, circle IB, circle IC are X circles of the triangle ABC. So roughly say we can have IB here, sorry, IA here, B, C, A, about here. And we have IB here, IC here. And they are tangent to the side BCCAAB on XYZ. So we know that this point is X and this point is Y and this point is Z, right? The midpoint of altitudes on BCCAAB are X1, Y1, Z1. So the midpoint would be here and the midpoint would be, this one would be here, and this midpoint, I don't know, somewhere here, right? That's X1, Y1, Z1. And then we want to prove that X1, Y, Y1, Z, Z1, these three lines are concurrent on the incenter of the triangle ABC. So, for this problem, what we really want to prove is that we just need to prove X, X1, and I are collinear, right? Because if X, X1, I are collinear, that automatically means Y, Y1, I are collinear, Z, Z1, I are collinear, which means X, X1, Y, Y1, Z, Z1, they are all concurrent on the incenter of triangle ABC. So, let's redraw the figure and think about the problem. Again, the first thing is that we want to simplify the problem. So, A, B, C here. So this is x. Let's call this point as let's call it as P. And I want to mark the point of, because we're going to use the incenter here. So let's say that the incenter is tangent to BC on point D, right? We have I here. So we want to prove that the midpoint of AP, which is this one, let's call it x1, right? We want to prove that x1, I, and x, these 3 points are collinear. If you follow my last video, we can brute force calculate it. And that's the way I think the most straightforward or easiest way to solve this kind of problem. Because so many segments are known in the in-circle, X-circle figure, right? For example, let's say how can we do the calculation? The idea is easy, is that if xi, x1 are collinear, if these 3 points are collinear, then we must have the following ratio, following equation to be valid. That's xd to xp equals to id to x1p. Right, this must be valid. xd to xp equals to id to x1p. So the question is that, can we prove this? If this is valid, then xi, x1 are collinear. Now let's see, what is xd? xd equals to bc minus bx minus cd, right? If you remember what we did in the foundation of the Olympiad geometry, we proved that cd equals to bx, but we can do it again here. Think about, we have a, let's call this point as S, right? Think about that IAS is perpendicular to AB, and let's draw another thing here, call it T, and IAT is perpendicular to AC. And we already know that IA is angle bisector of angle BAC. And we know that IAS is perpendicular to AB, IAT is perpendicular to AC. That means the triangle ASIA is congruent to triangle ATIA, which means AS equals to AT, right? AS equals to AT. And we already know that BS equals to BX, CX equals to CT. That means AS plus AT equals to AB plus, so let me write it down. AS plus AT equals to AB plus BS plus CT plus AC. So it equals to AB plus AC plus BX plus CX equals to AB plus AC plus BC. Right? Which means AS is half of A plus B plus C. Which means BS equals to AS minus AB equals to half of A plus B plus C minus C. So it equals to half of A plus B minus C. Right, that's BS. And for CD, we know that CD plus BD, or let's call this one as E, this one as F. So we know that CD plus BF plus AF equals to half of A plus B plus C, and AF plus BF is C. So that means CD equals to half of A plus B minus C, right? Then we know that BS equals to CD. So here, this BS equals to BX, right? Then here we know that XD can be calculated as A minus twice of this, right? So minus A plus B minus C. So it equals to C minus B. That's XD. That is XD. And what is XP? XP equals to BC minus BX minus CP. So it equals to A minus half of A plus B plus C minus CP. What is CP? CP is A squared plus B squared minus C squared divided by 2A. Right, we calculated it before. That's the length of CP. So it equals to half of A minus B plus C and minus this one. So it equals to A squared minus AB minus AC minus A squared minus B squared plus C squared, right? So it equals to minus B minus C B plus C, right? So it equals to let's write it this way, C minus A minus B times B plus C. I feel something wrong. This should be minus C, right? Bx, the length of Bx is A plus B, half of A plus B minus C. So this should be minus C here. Then here should be half of A minus B minus C. And this would be plus C. This would be B minus C. So this one, it equals to, let's move B minus C out. And, so C minus B, A plus B plus C divided by 2A. Right, that's the length of XP. So now we have the XD to XP, right? XD to XP equals to C minus B to C minus B, A plus B plus C to 2A, which equals to 2A to A plus B plus C. Right, that's XD to XP. Now look at, we want to prove that ID to X1P. What is ID? ID equals to twice of the area of triangle ABC divided by A plus B plus C, right? And the x1p equals to half of AP, which is twice of the area of triangle ABC divided by A times 1/2. So it equals to the area of triangle ABC divided by A. So ID2x1p equals to this one divided by this one. So that's 2A to A plus B plus C. Right? Now we can see that this one equals to this one, which means this is true, which means xi, x1, they are collinear. And that is saying y1, I are collinear, z1, I are collinear. So x1, y1, z1, they are concurrent on the I. Okay. These are two properties that we introduced today, and I think the first one I already proved it somewhere, but it's still a good refresh for the properties of the IA, IBIC. And for the second one, I think it's just because brute force is the easiest way for me to think of. Welcome to show me the pure geometry method. Okay, I hope you like this video. See you in next one. Thank you.